Hi, good morning, good afternoon, good evening, whenever you are watching this video. This is your video for week 6, lecture 2, and continuing on with our topic, which is binomial theorem. So we learned about permutation and combination. So now we're going to move to binomial theorem expansion. Okay, question now, how do you expand this x plus 2 to the power of 2 or x plus 2 square? So we usually do the old method you've been doing is the FOIL. You just write it side by side and then you multiply and then you get your answer. Okay, what about x plus 2 to the power 3? Yeah, okay, we can do the same thing. We write it 3 times and then we multiply and we get the answer. So what if increase the power? What if the power keeps on increasing? And what if it's to the power of 10? Do you think this way of calculating x plus 2 to the power of 10, you have 10 brackets and then you multiply each and every bracket using FOIL? You think that sounds easy, or is that even possible? You are very prone to making a mistake. Okay, so that's why we use binomial theorem. Binomial theorem is a way for you to expand binomials, which dealing with two terms, to a power of high power. Like for example, this one, binomial can let you expand the lemmalia easily. Okay, so here's the formula. So if you are given a binomial with to the power of n, so x plus a, x representing any number as well as a, any number, to the power of n, any number as well. So what the formula? So it's a summation where n from k equals to 0 to n, and then multiply to n c k. Now we already see this is combination, and then multiply again to n to x to the power of n minus k and a to the power of k. Now we already n le o le sau mai I o le k le sau mai I le value le. The value there increase ka ulunga nga way le summation there means addition. So you're adding from k equals to 0 to k equals to n. Your x layer, it's from whatever term that is in here. And for a, is whatever term that's here. So x above n minus k and a to the power of k. Okay, let's do that. It's an example to make it simple. So let's expand x plus 2 to the power of 4. So sub in the formula. So that's doing from k equals to 0 all the way up to k equals to 4. Because I'm going for the 4 little n. And we have 4ck times x to the power of 4 minus k times 2 to the power of k. So only 4 remains the same, remains constant throughout the whole calculation, but you keep on changing the value of k, increase from 0 to 4. So example, there, that's 4, lower sub k equals to 0, then 4c0 times x to the power of 4 minus 0 times 2 to the power of 0. Okay, plus la, yeah, so we value k to 1, increase to 1. Yeah, 1 for E, 1 E. We are just replacing the K here by 0 here. Replace the 1. Same, replace the 2. And then we also replace the 3. And lastly, because it needs to reach 4, replace for here, 4. Yeah, after that, you stop at 4, because 4 is the last number on here. So you stop at 4, and then you calculate using your calculator. Sabi ko mo values here. So for example, sub in 4c0, you type it on your calculator. Yeah, locally, which is I'm gonna type in my calculator. You get 1, and 2 to the power of 0 is also 1. So you're left with x to the power of 4. Plus, if you type this in your calculator, 4c1, you get 4. X to the power of 4 minus 1, x cubed, and 2 to the power of 1, 2. Plus, same case, 4c2, 6. X to the power of 4 minus 2, x squared, and 2 squared, 4. plus again. Same case with this one, 4c3 and more 4. X above 4 minus 1 le more x above 1 le, or just x. And 2 cube le more 8 le. And lastly, for this one, 4c4 and more 1. Yeah, that's x above 4 minus 4 more x above 0. And 2 to the power 4 le more 16. Okay, try and combine everything because 4 and 2 le multiply to get 8. 6 and 4 le multiply to get 24. 8 and 4 multiply as well. Okay, let's multiply that out. So x above 4 okay. This is 8x above 3, 24x squared, 32x, and 16. Because any number to above 0 equals to 1. Left lola on 16. And that's your answer. How simple was that? Okay, now let's expand 2x minus 3 to the power of 6. Same case, we apply this into a formula. We always start from 0 here all the way up to 6 because we'll n or the 6. So whatever power is out e, ikong suya e. Yeah, low formula, the 6 layer remains the same, ck, a to the power of 6 minus k. Sorry, or a there, yeah, it's this first term. So I changed the letters, but it's still the same. Or a there represents the term more, or b represents the term long luo. So 6 minus k, yeah, minus to the power of k. Yeah, sa puri kong kako formula sa. So k equals to 0. Yeah, sabi kong ule 0. Ile melia, sub everything in. Yeah, k equals to 1. Magkuala ule k. Increase k from 0 up to 6. Yeah, sub puri kong k, values of k. What remain 6 remains the same. Everything else remains the same. So you sub all the way up to 6. Your values of k. So as you see the formula, 6 remains the same. So it's 0, now it's 1, now it's 2, 3, 4, 5, 6. Even that for this guy, 0, 1, 2, 3, 4, 5, 6. And same with here, 0, 1, 2, 3, 4, 5, 6. Okay, simplify. 6c0 and only 1. 2x to the power of 6 there. You have negative 3 to the power of 0. So I just simplify 1 by 1. Okay, if I skip no. I just simplified them 1 by 1. So for example, 6c1 and more 6. 2x to the power of 6 minus 1 and more 5. Negative 3 to the power of 1 left. Yeah, same with all thing. I better pattern a little bit more. We have, okay, we have 1, 6, 15. Yeah, we're going to learn about that later. But the powers of where the power is 6, 5, 4, 3, 2, 1, 0. The powers are starting from 6, decreasing down to 0. Bottle E, the powers are starting from 0, increasing up to 6. Have you seen the pattern here? So we kind of get the pattern from the formula. The power of the first term, makamali 6, which is n, and then decrease all the way down to 0. And this, the power of the second term, which is negative 3, you start from 0, and then you increase all the way up to 6, which is the power. Okay, calculate that using your calculator. Combine, just multiply everything using calculator. You get your single terms. Because remember, negative, because the power of negative is an odd number. Yeah, negative la, if I even number the power. For example, negative 3 square, more positive. Little odd number, 3 cube, negative. Even 4, so more positive. That's why you have this power negative positive here, because it's depending on the power or the negative number or the negative term. Okay, and that's your answer. Yeah, you just add everything out. The what you got from here, just add everything. And remember where the minus is, the negative becomes a minus, plus, minus, plus, minus, plus. And that's your final answer for expanding this guy. Okay, so that's using the formula. Now we're going to use Pascal's triangle, which is kind of like a shortcut on how to expand binomial. So the Pascal triangle, it's this triangle. Triangle, it constructs by itself. So you always start with 1, 1, 1. Ke amaka le 1 le, kusile le 1e, kusile si 1e. And then, o kafa o malala triangle le, they all equals to 1. The edges. So how to get the 2? So you multiply, you plus the 1 le 1 le. That's how you get 2. Le row le, 1 plus 2 le mo le 3 le, 2 plus 1 le mo le 3 le. Okay, E, so 1 plus 4 you get 5, 4 plus 6 you get 10, 6 plus 4 you get another 10, and 4 plus 1 you get 5. Same with here, 1 plus 5 you get 6, 5 plus 10 you get 15, 10 plus 10 you get 20, 10 plus 5, and so on. So you keep on adding this, adding your terms here. So that's the Pascal triangle. By numbers here, I kako previous numbers here. 1, 6, 15, 20, 15, 6, 1. Right, 1, 6, 1, 6, 15, 20, 15, 6, 1. If you look at one of the columns of the Pascal, 1, 6, 15, 20, 15, 6, 1. But why this column? Yeah, I'll get to that later. Okay, so these columns are, or what you call, these are the levels. So this is the 0th level, level 0. First, second, third, fourth, all the way up to this triangle is actually infinity. It is the end. But I'm stopping here because we don't get that far. Okay, so let's expand 4. X plus 2 to the power 4. So if we have the 4th power, we look at the 4th row here, and you just extract those numbers, ilalu. So we have 1, 4, 6, 4, 1. Okay, and then we bring the first term here and multiply it across. So yeah, up here. So first term there, you start from positive 4 because of power nga, and then decrease the power ilalu, ikaw 0. Remember in the previous slide, I showed you the patterns of the powers. Yangala, we are applying that here. So same with 2 here, second power, the second term, makamali 0, nga increase wala ikaw ay lunga le 4, or ikaw ay lunga le power. Yeah, and then you add everything up. Yeah, calculators, do your calculations. Therefore, your answer is that. Right, very simple Pascal triangle. Okay, you can pause the video. Have a look. Okay, so here's a class activity for you. I have given the answer, so please try and do it by yourself. In the test, I won't specifically ask for you to use a method, a Pule method to expand. You can even use the FOIL method, that's up to you, but as long as whatever method you are using, you are comfortable with and you get the right answer. But I'm not going to specifically say for ngase formula or for ngase Pascal triangle or for ngale FOIL. That's up to you. Whatever method you feel comfortable using, use it. Test. Test 2, that's in week 7, which is week after next. Okay, pause the video here, try and do it by yourself, and then I'll show the solutions in 3, 2, 1. Okay, I also uploaded our tutorial questions up on week 6 for this topic. So please, if you have your free time, which is you must have free time to do it before your test. That's the end of our lecture, and also you have your homework here. So yeah, for whatever time you have, please do your homework, and that's the end of our lecture. Solution homework. If you wanna check your solutions, we have solutions here for the homeworks, and that's it. I'll see you when I see you.